I'm going to discuss about the assembly language code of keypad interfacing with 8051. Now, if you have followed my previous lecture, there I have mentioned what is the configuration I am using here. So if you can remember, in the last lecture I mentioned that port P2 was connected to these vertical lines of the keypad, and as it has four vertical lines, so the connection was from P 2.0 to P 2.3. So P 2.0, 2.1, 2.2 and 2.3 for these vertical lines, and port P1 of 8051 was connected to this horizontal line. So it means P1.0, P1.1, 1.2 and 1.3. These are the lines. Okay, connected to port 1 of 8051. Now, this is the basic configuration what I considered. And other than that, if you can remember, to write assembly language programming, you have to follow three steps. And these three steps I discussed in my previous lecture using a flowchart. Now, briefly, I will tell what are the steps you have to follow. First of all, you identify whether any key was pressed or not. This thing you find it out. Now, in the first step, if you are finding that key was pressed, but you cannot come to a conclusion that definitely the key was pressed. I talked about the key bouncing effect in my last class or in my last lecture. So because of bouncing effect also, though the key was not pressed, but still you can observe that the key was pressed, which is a wrong thing. So you cannot directly come to a conclusion that the key was definitely pressed after going to the after checking the condition of step number 1. So that's why you need to cross verify once again in step number 2 whether the key was definitely pressed or not. How to do that? After checking in step 1, again you need to check the same thing after 20 millisecond. As I told, the debouncing effect comes after 20 millisecond only. Okay, so after 20 millisecond again you can do the same type of checking in step number 2 to come to a fixed decision that the key was definitely pressed, or is it because of some noise effect you got that the key was pressed. Okay. And finally, in the second step, if you are identifying definitely the key was pressed, in the third step, you need to identify which key was pressed. Now, how to do that? What I told in last lecture, you have to activate one of the row at a time, and you need to find out which row, which key was pressed from that particular row. Okay. And that discussion I have done in my last lecture. Now, in this lecture, I am going to discuss about the assembly language code. Now, so see the first line, move P2 comma 0FF. Now, as I mentioned, P2 uh, was connected to the vertical lines through which controller was scanning the data. So it means the value what you are getting through P2, this is considered as an input for the processor, sorry, for the controller, 8051 controller. So as P2 is used as a input, so it has to be assigned FF value, because in case of 8051, you know, when some port is assigned as an input, the by default value should be FF. And if some port is assigned as an output, the by default value, what you should initialize, that has to be 00 only. Okay. Now in this case, P2 is used as an input. That's why I initialized as 0FF. Now the next line, move P1 comma 0. Why it is done? Because if you can remember in the last lecture, I told, first of all, to identify any key was pressed or not, you need to make all the row 0. How to do that? And all the all the rows were connected to P1. So that's why I'm making P1 equal to 0, 0. It means I have made all the values equal to 0. Okay. After that, what you have to do? Check the value of P2 and find it out whether the value is 1111 or something else. Now, how to do that? So after making all the P1 value equal to 0 by this line, what you have to do? Move A comma P2. What we are doing here? Currently, whatever value I am having in P2, that I am bringing to accumulator. And after that, I have to do AND operation. Why I have to do AND operation? Because if you can remember how many bits I have used from P2, only the last 4 digits or 4 bits. What about the remaining left side 4 bit? Because if you can remember, in every port of 8051, it has 8 different bits or 8 pins are there. Now for this current problem of this keypad interfacing, I am using the right side 4 bit. Just in the beginning itself, I told I am using P2.0, P2.1, P2.2 and P2.3. Up to 2.3 I am using. So this right side 4 bit I am using. What about the left side 4 bit? These are not my concern. So I need to deactivate those left side 4 bit. So what is the best procedure to do that? You simply do AND operation with 00001111. So 0000 means last 4 digits will be deactivated as you are doing AND operation. This will end result will be 0, and in the right side whatever bit you have based on this AND operation, same value you will be containing because you are doing AND operation with 1. This is the basic digital electronics concept. Okay. So you see A and L, A comma 00001111. By doing this operation, whatever value I am having in accumulator that I got through P2, that has ended with this value. So after doing this AND operation, what it is happening? The result is getting stored in accumulator. What result? The left hand 4 bit I am deactivating, and my result will be based on the right side 4 bit. Now what I have to do? I have to check what value I got in the accumulator which has come through P2. Is it 00001111 or not? Why I am checking with this particular bit combination? The reason is if it is 111, right side 4 bits are 1111, it means no key was pressed. If it is any other value, uh, means if any of the value is 0, or if, other than this value, if you got any other value, it means there is a chance that key was pressed. So that's why the simple instruction what we use in such cases, CJNE, compare and jump no equal the current content of accumulator with this fixed value of 00001111. If these two values are equal, it means key was not pressed. If these values are not equal, then there is a chance that key was pressed. So Cj any a comma these things, this particular value comma k2. So if they are not equal, you have to jump to k2. Means there is a chance that key was pressed. And if these two things are equal, what you have to do? Short jump to K1 means again you need to follow these steps. So these things I already mentioned in my last lecture where I talked about the flow chart. So from there you can easily understand. If these values are not equal, what does it mean? Means definite there is a chance that key was pressed. If these values are equal, then definitely key was not pressed. You need to do the checking once again. Okay. Now let's come to this particular thing. If the values are not equal, so you have to come to K2, then you have to do a call delay. What you are doing here, you are waiting for 20 millisecond delay. So you can write one delay program to get 20 millisecond delay. That is a very simple thing. Okay. So a call delay. So you are waiting to complete this bouncing effect. Now after that, again, you need to follow all these steps. What you have to do? Again, take the content of P2 what you got that in accumulator after 20 millisecond, you take the value of P2 in accumulator and then do AND operation. Why? To deactivate the left hand side 4 bit, only just activate the right side 4 bit, and then again you do the comparison what you have done in this case. Now in this case also, if the values are not equal, then you can definitely come to a conclusion that definitely key was pressed. If the values are still not equal. Okay. If the values are still not equal, you have to come to over1, this particular tag. And if they are equal, it means key was not pressed. Again, you need to come back here, short jump to K1. Again, you need to come back here. Okay. Now we can come to this particular tag over1. When the values were not equal, it means definitely the key was pressed. So in the second step, if I find the values are not equal, it means definitely my key is pressed. Now what I need to do in third step, I need to find out which key was pressed. So how to do that? If you have followed my last lecture, there I told you need to activate one of the row at a time. So how to do that? You have 4 rows, row number 0, row number 1, then row number 2, then row number 3. Activate one of the row at a time. Suppose if I am activating row number 0, what should be my pattern? 0, 1, 1, 1. It means I have made my first row 0. It means I have activated my first row. How to do that? You see move P1 comma hashtag 1111, last value is 0. So it means last value is 0 means I have activated my row number 0, which was given through P1 port. This is the last bit. If you can remember, in the last class also I mentioned, or maybe in the beginning of this lecture also I mentioned, P1.0 was connected to P1.0 was connected to row number 0, and P1.1 is connected to row number 1, and so on up to row number 3. That is P1.3. Okay. Now if you come back here, so the last bit, that is row number 0, I have activated the first bit. I have made 0 means first bit I have activated, remaining bit values are 1, and I no need to bother about the left side 4 bit. So in this case, I have activated my row number 0, and in that case, let's scan the value of P2. P2 means the column value, you scan it. Okay. And and after scanning the column value, do the AND operation to deactivate the left hand side 4 bit, what you have done in this case also, or maybe in the previous case also, and just take the right side bit and compare and jump no equal. So what you have to do, whether what value you are having now in the accumulator, whether this value is equal to this or not. This idea is exactly same as this idea and this idea. If they are not equal, then it means the key was definitely pressed. If the value is not equal to 1111, then definitely the key was pressed from the row number 0. Okay. So you have to come to row number 0 tag. And same thing you need to follow for row number 1. How to activate row number 1? You have to make the 0 as 1, first row as 0, then 1 1. So for row number 1, if you want to activate row number 1, the pattern should be 1 0 1 1. In this case, I have activated row number 1. Same thing, whatever I have done for row number 0, same thing I have to do for row number 1. So now see, what is the pattern for row number 1? You see this pattern. The next bit is 0. Okay. And same thing I have to do for row number 2. In row number 2, what should be the pattern? 1 1 0 1. So this is my row number 2. I've activated my row number 2. You see, now this third bit will be 0. This one. And same thing I have to do for row number 4. That is 1 1 1. So in row number 4, 1 1 1 0. So 1 1 1 1 0. This is for row number 3. Row number 0, row number 1, row number 2, row number 3. So four different conditions are given for these four configurations. Okay. Now for each of the configuration, if it is satisfied, means if these are not equal, then definitely Q was pressed from row number 0. If these are not equal, then the Q was pressed from row number 1. If this is not equal, then the Q was pressed from row number 2. If this is not equal, then the Q was pressed from row number 3. Now for each of the row, you have to uh, define that particular keys. Okay. So whatever row is getting satisfied, you have to come to that particular row and you need to make ready of your DPTR. Okay, DPTR register. So for row number 0, what tag we have used in the previous case on the previous page, you see this level is row number 0, this row number 1, row number 2, row number 3. If any of this condition is satisfied, you have to come to this particular row tag. So what we are doing for row number 0 tag, move dptr value equal to hashtag kcode 0. What is hashtag kcode 0? This is the level which I have used to store the 4 key values in my lookup table. In the first row, you had the keys as 0, 1, 2, 3. If you can remember the last picture, the key was 0, 1, 2, 3. And for the next row, 4, 5, 6, 7. Next row, 8, 9, A, B. Next row, C, D, E, F. So you see, these are the values only stored in those four: K code 0, K code 1, K code 2, K code 3. This is for row 0, row 1, row 2, row 3. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay. For each of the row, 4 keys are saved. Okay. And you know, for that you have to use DB syntax. Okay. Starting from any org location, we have considered here 300. You can take something 500 also. It's your wish. This is for row 0, row 1, row 2, row 3. These are the key values I have saved. We will take these key values and check which key was pressed. Now, so move dptr comma hashtag key code 0, that is for row number 0. Same thing you need to do for row number 1. Same thing you need to do for row number 2. Same thing you need to do for row number 3. Now after that, what you have to do in each of the case, e- each of the case you need to come to a particular operation. Find here also find, here also find, here also find, here also find. Okay. Hereby automatically you will come to this line. Now find what operation is going on in the find tag. So just if you have followed my previous lecture or in the beginning of this lecture also I told after identifying the row number, next job is to identify which key was pressed from that row. How to do that? A very simple operation. Rotate right with carry the accumulator content. Rotate right the accumulator content with carry. So whatever content you have in your P2 port, which you brought in accumulator register, currently you are having an accumulator register. For example, you have this pattern. So what does it mean? Each of the time you need to rotate the value of the accumulator through the carry flag. When the current value of carry flag will be 0 means that particular key was pressed. Okay. So you see rotate right carry content, rotate right with carry accumulator content, jump no carry. Jump no carry means jump when the carry value equal to 0. Where to jump? In this match tag. What we are doing here in match tag, clear the content of accumulator. Why? Because the next instruction is move C A comma A plus at the rate DPTR. As you have to access each of these values and you have to increment the DPTR to check next location. So in this operation, as your by default instruction is A plus DPTR, this A should not create any problem to do the accessing. Okay, your DPTR should be incremented by 1 unit every time. So in this operation, if you have some by default value of accumulator, that should not make any disturbance here. So in order to do that only, your accumulator value should be 0 before using this instruction. And you have seen in most of the cases, while using this instruction, you have to make first accumulator value equal to 0 so that it cannot make any disturbance here. So I am clearing the content of accumulator so that I can use this instruction move C A comma at the rate A plus DPTR. Now whatever DPTR value I am having, that content is getting loaded to accumulator. This register is not creating any problem. Okay. Otherwise, this will move to some different location which is not indicated by DPTR. Okay. If we don't make the accumulator value equal to 0. That's why we are making the value of accumulator equal to 0 before using this instruction. Okay. Now let's talk about this one. Move A comma at the rate A plus DPTR. So DPTR current content will be loaded to accumulator. And when this condition will be satisfied, when this condition is satisfied, when you will come to match, you will come to match when your carry value becomes 0. And when your carry becomes 0, when carry value becomes 0, it means that particular key was pressed. So that key you can display in P2 port. You can use P2 port to display that key value. So move C A comma at the rate A plus DPTR through which you are taking that particular key value, and that is there in accumulator, that you have brought in accumulator, and through accumulator you are showing that key value through port P0 that we are considering for this particular assembly language code. You can use some other port also, and then long jump to K1. Again you need to come back to K1 to do the checking for the next case. K1 means is this level here to do the scanning for the next key pressing. Okay. Now, if you just discuss this point once again, suppose if you are not getting, when you come to match tag you are coming to match tag when your carry value equal to 0, then only you have to come to match. If, for example, I have got this pattern 1101 for the first iteration, is my carry value equal to 0? No. So it means it is not satisfying the jump no carry condition. In that case, what you have to do? Increment the value of DPTR. So you access the next location. DPTR was indicating the first location for the first row. Now, as the first value is not satisfying this condition of carry equal to 0, then check the next value. Means you increment the value of DPTR and then rotate the content of accumulator one more time and check whether the carry value is becoming 0 or not. If it is 0, it means that key was pressed. So what is the logic? If this jump no carry condition is not satisfied, then increment the DPTR and short jump to find and go for the next iteration. Okay. And if it is satisfied, come to match and display that value to the P0 port. Understood? Now, one thing, let me tell you here. If you can see, the uh, pattern of the key was like this way. uh, 3, the order was 3210. This is the order. Then 7654. But how we have saved the value in lookup table? We have saved the value in the opposite order 0123. Why? Because we are doing right rotation and DPTR is indicating this value. Try to understand. Your key was, if you can remember, this was your key 0, this was your key 1, this is 2, this is 3. Okay, and this content you are having in P2 port, which has come to accumulator for this operation. So for example, if your pattern is 1101, which key was pressed? Definitely 1 was pressed. Okay, so definitely you need to save the value not in this order. You have to save the value in the reverse order, that is 0, 1, 2, 3. Then only when you will do the rotation for the second time, the assigned value is 1 and you will get 1 also from here. Okay, but if you write the same order what was there in the keypad, same order if you write, then you had to write it 3210 in these places, and that will indicate a different key value, not the corresponding key value. So I think hopefully it is clear to everyone. If you have to get the corresponding key value, it has to be written in the reverse order because you are doing right rotation. Okay, so thank you so much.